Okay, so let's remind ourselves where we left off last time. So we basically just started a new project and wrote a function that renders a cube. We created a bunch of triangles and then proceeded to render these triangles. Okay. So this time I want to get this cube moving. I want to press arrow keys on my keyboard and have this cube rotate and move around. I want to do that more than thinking about data structures that draw triangles. So let's just work on this tonight, and then later on we'll think about some sensible stuff to do this with. Okay, let's first change the camera angle from down here. This was a weird place to leave it off last time. Okay, and then what do we want to do? I think before we actually start moving the position of this cube around, we want to start rotating this cube. Rotation is like easily done, okay, not easily, but done with quaternions when you know what they are. When you know what they are, they're simple, but the problem is most people don't know what they are. And even when you do know what they are, and you know there's this beautiful homomorphism from unit quaternions to SO3 that that you can take the quotient of that and you actually get a diffeomorphism from RP3 to SO3. Most people don't know what that is, and I think it kind of complicates the code anyway. So I kind of just want to keep track of this cube, the actual position of this cube, with 3x3 matrices, and then when we'll animate it, we'll just have like 3x3 rotation matrices. Like it will. I think this is the way to do it. We might have to change it later on, but for now, this is what it is. Okay, so we want to say, in addition to just this cube and the position, we also want to add in some like matrix with which we're going to multiply everything in here. Looking at the way I've laid this out, I don't immediately like it because the center of this is not zero. And what I want to do is I want to apply some rotation to all of these points here. And that will require that all of these points are basically have a center that is the origin. Okay, so let's just add in a rotation matrix parameter to here as well. So we have this position, and then we also have a rotation. How do matrices work in Z? I've forgotten. Let's just check this out. Documentation. Is there a built-in type for matrices in Zig? I'm not seeing it. If not, we can just create a fixed array of 9 floats and do that instead. Yeah, I'm not seeing this. What's the issue of this? I just want to pull out the LRM. Interesting, okay. Like, yeah, Odin has matrices, but not Zig. That's fine. We'll just define our own. Okay, so let's just do... what, mat33, what's a good name? I think like a 3x3 matrix like this is fine. Does it make sense to do this? So these floats are 4 bytes, so this would have 36 bytes. So it hasn't completely ruined a cache line. But it still kind of is bigger than... I don't think this is necessary. Let's just leave this as 9 floats. And then like in Odin, since matrices are a built-in type, vector multiplication by matrices is also just taken care of. Operators are overloaded to do everything. It's okay. Here requires something a bit different. Even so, I think this is fine. Like, it won't be too bad. Okay, so I think the first thing to note is to think about how we're going to implement rotations for these cubes and positions. So what I want to happen is when a button is pressed, like the frame is, like a key is pressed, on that frame, or at the very least the next frame, the cube is like automatically rotated into basically its like final position and orientation. And then we start playing an animation that kind of like reverses back in time and then shows what's happening to it. Like a huge pet peeve of mine in so many puzzle games is you press like a grid-based puzzle game, you press some arrow key to like move the character to the right, and then let's say you press this arrow key like 5 times really quickly. In good puzzle games, after pressing it 5 times really quickly, like you just end up on the final square. In bad puzzle games, the game ignores your input after the first press and waits until the entire animation is played out. I want to completely avoid that. We're not doing that. In this game, this is my game. I want to press the arrow keys really quickly and the cube is fine. So this said, all of these rotations of the cube we're doing are just going to swap the axes around, and so all of these 3x3 matrices will actually just be zeros or ones or negative ones. So we can actually define a matrix type which is just I8s, like 9 I8s, but what should we call this? I think I always have it like mat 33 I8 and F32. This is, you know from the type what's happening. So actually, yeah, so let's just now add in some constants which just like represent rotation around by like 90 degrees around like the x-axis, y-axis, and z-axis. And then in the game we'll have to like figure out, depending on which, okay, we'll do this to start with. We'll just get this working so that like left corresponds to a certain rotation, down corresponds to a certain rotation, etc. And then depending on like with this fixed camera position, like there's going to be some math, but it's fine. We'll get through it. So let's say like constant x rotation is really vague. I'm going to say like x pi on 2, but that's not. What about x rot 90? This is fine. Then make this equal to this mat 33 I8. Let's think about what this matrix will be. So if it was the identity matrix, it would just be this. And actually, we really should have an identity matrix. What should we call this? Like identity 3 by 3 I8. It's a horrible name, but whatever. Now we want to do rotation by x that is the best name I can come up with at the moment. Rotate x by 90 degrees. Actually, we're going to make all of these just like the obvious ones. Okay. Okay. So if we're rotating around the x-axis by 90 degrees, then we're permuting the y and the z. So in particular, what we end up with 0, 1, 0, 0, 0, something, something, 0, something, something. Okay, this one here should be the cosine of the angle. Cosine of 90 is 0. This will be negative sine of the number, which is 1, so that should be 1, and then we should end up with 0 here. Okay, and now we want to do something similar, but now with rotating by y along, by 90 along the y-axis. Okay, so this time something 0, something, we're fixing the y-axis, something 0, something. So now this should be cosine of 90, which is 0, negative 1, 1, 1. And finally, we want to rotate by 90 around the z-axis. I was telling myself that in the future, Zig will have matrix tags. This was unexpected. 0, something, something, 0, something, something, 0, 0, 0, 1. And this is just going to be as usual, 0, a negative 1, 1, and 0. Okay. Okay, so now we've got those. We now want to keep track of our cube's orientation by like an overall rotation matrix. So now we need to define some functions for them. This is fine. So we could say function matrix multiply, which is just going to take in two matrices, and we're just making this the simple I8. Then we'll return a one of these. I think, like, does Zig have polymorphism? I kind of want to just like write this function in a way that like doesn't depend on the type. But honestly, it doesn't matter that much. We're just going to be multiplying either these matrices that have floats in them or these simple matrices that only have ones and zeros. So it should be fine, I guess. So we just want to say here, we just want to return this 3 by this is like tedious. It's fine. Let's do this. So let's just make this matrix be like A ij, and then this map2 is bij. Already I'm regretting this. It's fine. It's fine. The compiler will get rid of all of this. So I think we can just say right, like writing the definition of matrix multiplication when you actually have like a double array of things is really simple. I feel like this is actually what we should be doing. Okay, we'll leave it like this. And macro. Before I start doing any of this, let's just check this compiles. Okay, 189. Okay, it's fine. Back to matrix stuff. Yeah, so now we want to do this. So we got all of this. So I think we just want to say like this really should be a constant. But I think it's just, I think the compiler will force us to make this a variable. So you can just say, make this undefined. And then we want to say for 0 going to, for I and j going from 0 to 2. We simply want to say that this is not the way to do it. The return matrix is, we need to get this order right. Call this ji. This is going to equal the result of another for loop, which is how are we going to do this? So let's just say product, or really sum, is equal to 0, and then we want to say now for 0 going to 3 of ijk. You just want to do sum plus equals. This is fine. Sum plus equals mat1 I so yeah, like linear algebra tells us this is the formula, but what's the correct indices formula? So it really should be IK. Is that right, or is actually, I think it's that. So we now need to do, yeah, this actually represents the no. So yeah, IJ represents, I'm getting all of these wrong. So if we're iterating over I here, we're actually iterating over J. The columns are indexed by I. I mean, the rows are indexed by I. The columns indexed by J. And so when we want to take the ith row and the jth column, we want to take the ith row and the jth column. Okay, so we actually do want this. Yeah, okay. And then we just want to set this one to the sum. Okay. And then we just want to return this. Okay. Let's make sure this is behaving. So let's multiply each of these things by themselves 4 times, and then the result should be identity matrices. We could write this as a test, but let's just put it inside the main for now. Okay, so let's just do variable matrix here, which will equal now the x rot 90, what do you call it? Rot x 90. And then we just want to say for for a loop where we're going to multiply this by itself up to 3 times. Let's print this out. Format.debug.standard.debug.print. Can I do any and then we want to do mat is equal to mat multiply mat by rot x90. Okay. Build. Let's give this a go. Okay, and then we're saying expected loop payload. Yes, this is an unused captcha. I just want to do this several times. I guess I should be using a while loop then. How would I like just okay. In Odin, everything is a while loop, hence the adjustment. Everything is a for loop. So you just want to say while. Size. I think usize is fine, right? I is equal to just like 0, and then, or I is less than equal to 4. At the end of every loop, plus that once. Must be constant or comp time. I guess this is because this is an I8. Okay, and then let's see. So yeah, X rotation. Okay, I see the identity matrix here. So this should then be yeah, rotating around the x-axis twice is just going to be inverting the x and the y-axes. Great. Okay, like how do we do this? Like x, y, z. Oh, I guess this depends on whether it's like right-handed or left-handed coordinates as well. So yeah, definitely rotating it twice inverts both of these, and then rotating it 3 times should do what? Should kind of get us back to that. So then, yeah, this seems to be working. Okay. So let's just like, we should actually do this as a test. I want to just like leave this as a to-do. Like the ultimate test is whether we actually just rotate this cube at the end. But we can just do this. Make test for matrix. Okay. Done that, and so now we have this presumably working. We want to now just keep track of where the cube is and rotate it appropriately. So if we go back to main, let's make some global that represents. Ooh, we're gonna have to start breaking this function up. No better time to do it. So let's do like a process input function, then we can have render function. We just want to move all of this stuff into the render. So function render void, and then should be. Is this going to whinge when I try and compile it? It knows everything. it should be fine. It knows everything here. Okay, so then we need to write a process input function. I guess we really should do an update state as well. We can. Why don't we like just process input and update the state at the same time? For the moment. Oh, come on. It would have been easy if I just like, anyway. Process input update state. So we now want to just listen for when mouse keys are pressed and do stuff. So we'll just do like for debug initially, we want like left key or like left arrow is just like rotate X by 90. We'll make right arrow is just 3 of these, so really like rotate X by 270. Hang on, so yeah, Y is up, so when we're like rolling this thing, we're going to be wanting to roll it on the X and the Z. And for the up arrow, we'll do rotate Z by 90, and then presumably we'll do 270 for this. Okay, to do this, we need a global to even store this. But even before that, we need to read in from raylib what this stuff is. How did we do this in the previous project? Oh, in the previous project, we didn't actually do any key detection. We did. We did like escape should have quit the app. So but we didn't actually write the code for that. Okay, that's fine. We'll be able to do this in raylib. Question is how. Key press? Is key pressed? Yeah, this is what we want. I think we just want is key down and is key up. Okay, is key down. Key here is presumably, well, what is key? It's presumably some struct. So let's do like H key. Or what if we do like up arrow? Maybe just arrow. What about like escape? Like yeah, GOFW has a bunch of these things, but presumably raylib just has some wrapper for these instead. Function keys, keypad keys, alphanumeric keys. I mean, I guess that's what it is. 566. Raylib source, raylib.h, 566. Yeah, this is what we want. This looks good. So we just want to call this like key. Ooh, where's the arrow keys? So like key left. Oh, here it is. Okay, yeah. Key right, key left, key up, key down. That's what we want. Okay. Okay, so then we just want to call this, right? So, okay, we're gonna have to like set up some, in the same way that in the last app, we just had some like booleans noting whether the left mouse button or the right mouse button was pressed up or down. We want to do something similar here. So where do we do this? Let's use a keyboard. I want this game to be playable with only the space bar and the arrow keys and nothing else. The game will be too complicated. Like the game doesn't need to be any more complicated. So this will be fine. So you just say like left key down. This is going to be a bool. It's undefined. And then let's just start off with a single key. And then we can do left key down last frame. I'll make this a boolean as well. Okay, and then we actually want to set these things. So now we want to say left key down is equal to raylib.isKeyDown, raylib.keyLeft. Then we also want to say like defer. Oh, how does the defer logic work again? We want to basically say that we're setting the left key down was last frame kind of at the end of the frame. The worry here is if we set it just at the end of this function, is this kind of like are we setting this prematurely? Is this going to stuff up the logic in previous stuff? Actually, I think the way to do this is just to say the left key down the last frame is equal to whatever it previously was, and then that's now set, and then we just update the new one. I think that's all we need to do. Yeah, so you can say update. Yeah, this should be fine. Okay. Ooh, this is like undefined. One of these is going to be undefined to start with though, but that's... let's just say it's false, that it... when the game starts, we'll make both of these false. This should be... there's no bug should. no bug should come of this. Okay, so now we've done that. Now we can actually, the rest of the, let's see. I don't want to use is key up. I feel like it's unnecessary to do this. It should just be something like, yeah, this should be fine. Like if the key is not being pressed, this will set it to false. It's fine. Okay, and then yeah, the other stuff is here. When we get to it. Okay. So now we've actually done that, we want to rotate some matrix. So we can have like cube rotation is a global, and we want to say if the left key is down, and it wasn't the case that the left key was down the last frame, rotate this matrix. So we could say, we'll call it like the main cube. In this version, currently the game's going to contain one cube. This may change. We'll deal with the code when necessary then. So we can say the main cube rotation is then going to equal, was it the mat multiply the main cube matrix. Then if we're doing the left key, we just want to try this matrix here. Okay, we're going to have to make a global for this matrix. So why don't we say main cube rotation is equal to just the identity matrix to begin with, and then that should be fine. Okay, now we want to let's just like print a debug to make sure that pressing the arrow key is working as intended. And then we'll start applying this to the actual cube itself. So standard.debug.print. When was can I just copy the last debug thing we did? Here. Okay. And then here we just want main cube rotation. Okay, let's compile this. Use of undeclared identifier camera. I knew it was too good to be true. So 190. We'll just make the camera a global, which we can do by really just moving this line up to the globals. Okay, and yeah, great. Pressing left pressing the arrow key is doing what we want. See, identity matrix X inverse, or 180 degrees inverse. This seems to be working. Okay. Now let's start applying this to the cube, and then once this works, we'll implement the other directions. So if we go to like render cube now, render colored cube, it really should be called rendered cube. I don't know why I said this is render colored cube. there's only one cube in the game for now. Now we can actually take in the matrix. Okay. Eventually, this is going to have to be the float version of the matrix. But we'll deal with this for now. In order to apply this, rotate the cube and make sure it isn't wacky, let's change the coordinates to all of these so that these now have coordinates plus or minus 1. This is to say we want to replace all of the zeros with minus 1s and all of the 1s with positive 1s. So let's change all the 1s with positive, change some of the 1s with positive 1s. And then we want to change the zeros with negative 1s. I missed one. This is kind of messy. Let's space this out. Okay. And then before we start doing anything with the positions we're adding, we want to now rotate these things. Yeah, rotate the cube nodes by rot. So now we want to say basically like we should give these new names. Maybe like we'll change like O for old. That's not a good name. Maybe like U. Okay, so U, and then we just want to say okay, what do we want to say? We want to say, I think we just want to define another function that multiplies one of these vectors by the matrix. If we're dealing with everything that is already, if these are already F32s, it honestly makes sense to make this an F32. This is so much work, but we will get there. Okay, so let's first write a function that multiplies a matrix by a vector, and then we'll write the thing that converts, that just basically converts our I8 matrix to the appropriate one. Okay, so now we want to do a function like this. We truly are doing everything from scratch in this game, aside from the rendering, which we'll replace. So now we want to do like matrix vector multiply. Is this? I think that's fine. So let's see, we have just a matrix, which will make now an F32. And then we have a vec, which is a vec3. And we're going to be returning a vec3. And we just want to say that we're returning the thing that's equal to, this is tedious. I think we can just say the return vector is going to equal a vec3, it's currently undefined. And then we just say for I ranging across these values, we just want to say the return I value is going to equal the ith row of this dot with the vector, and so that's going to be this plus this plus this, and then we just do that 3 times, then we're done. I'm going to return that. Okay. So now let's call that in here. So now we just want to say constant p00 is equal to matrix vector multiply the rotation matrix with u00, and then we just want to repeat this for all of these other points. Let's copy this. So like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then likewise 1, 1, 1. I feel like I missed one. Or not. Okay, if this has any bugs, we'll hopefully see it visually. Okay, and then now that we've multiplied that, then we want to add in the position to these. So now we want to say plus pause. Plus pause. Okay. I guess nearly done. So we kind of want to scale all of these down by 0.5 as well. We could do like, I mean, why not implement like scalar multiplication for one of these matrices as well? There is some way of doing this in Zig, but I remember someone like, I think when I started out actually, I asked in some like forum, oh, in Odin if you want to multiply a vector or a matrix by a scalar, you just use times and it's overloaded. And then someone's like, here's how to do it in Zig, and it was like 5 lines, and I was like, that's ridiculous. Surely there's a better way of doing it. And someone's like, why is that ridiculous? And I'm like, someone has drank the Kool-Aid. Let's just like implement our own version. So we'll just do matrix scalar multiply at 33 at 32, and then it kind of makes more sense though to have be multiplying by the scalar out the front though. I feel like it should really be this. And then here we're simply returning the thing that we're returning here is just I mean, what's the easiest way of just brute force multiplying everything here by s? Whatever. Like this is a really simple game. There won't be like, there's going to be zero optimization, like penalties for just writing this as a massive group. So when you're doing all of this, simply have this return matrix. We're just copying this one, and then we're saying take this return matrix, take the ith j, and this is going to equal this thing. Presumably I can just say this. Okay. Then we're getting there. We're getting there slowly but surely. Now I can just have here, we want to do the matrix scalar multiply, take everything down by 0.5. Okay. Now we need to write something that will convert our I8 matrix into an F32. So let's just do that. So now we want to say mat33I8 to mat33F32, which will just have a matrix that is mat33I8, and then we're returning that, and we simply say it's just the usual. It's really the usual. I just want to say for, like, I'm sure there's some simple way of casting this. We're just doing this the dumb way. Well, not the dumb way, just the way that's super readable. For everything in here, this is just going to equal int cast mat ij. Return right. And that should, hopefully this should compile. So now we just want to say, so now when we actually render this cube, now we need to do like all of the globals and everything. So now we want to say cube position is going to equal the mat33I8 to our actual cube position, which was called what again? Main cube rotation. Main cube rotation. And then we want to just pass this in here. Okay, I think that's it. Let's try. This better not be what I think it is. The Z compiler better accept +1 as the integer 1. I'm going to be really pissed if this is the case. This is not good language design. I can understand why this choice was made, but at the same time, this is annoying. Replace this with just a space. Name shadows primitive. Where? 271. Oh no! Oh, this is using the compiler somewhere. Okay. We'll just replace these with C's then. What are we doing? We just want to replace this. Let's see. 227. Use of undeclared identifier pos 1. That's because why? This really should be a constant cube rotation. And here we want to do cube rotation. And then for the position, did we not want this at say like 202? How is this statement wrong? Okay, what's happening here? Expected type F32 found that. Did I get the type wrong? Yeah, what's happening? Did I not? That is what we think it is. Now I'm actually realizing if perhaps like if Zig has actually defined multiplication for vectors like this, then like we can actually simplify some of our code. We should add that as a test. Just quickly now. So let's make vec1 equal to, say, like 1, 2, 3. And then vec2 will be, let's say, like 0, 0, 4, 1. Then standard.debug.print. We just want to test if we can actually multiply these things, and if we can multiply them, if the result is equal to 0, 8, 3. Okay, this is like separate thing, but okay. Okay, this seems to be a different problem from last time. So 1, 2, 3. Expected integer or vector found F32. What? Why is this confused? Maybe it is related to this one. Expected a vector found this. What? What's happening? What if I actually got rid of the incast? This, I'm expecting the compiler to error this, at least. Yeah, it's expecting F32 and it's an IA. Yeah, so we cast it. Am I not using like the right? Windows, why are you too slow? Like, come on. If I type Firefox and hit enter, I expect to immediately resize the screen, which is Firefox. If we do int cast, where is it? Oh, okay. We're kind of doing like a float from int instead. So no, we want float from int. Okay, this is what we want. Okay. Float from int. Okay. 1, 2, 3. What on earth is, oh, I see. We're just copying the matrix one. Okay, let's move this back to here. Okay, now I'm getting the error here. Yeah, expected a vector found F32 instead. Oh, it's because we're meant to be multiplying the rotation matrix by a scalar first, and then wait. Yeah, this thing in the middle, this rot here really should be that. Okay, so we can say here, scale, like rot2 is equal to matrix scalar multiply 0.5 the rotation, and then yeah, delete all of this stuff. And then we just want this to be the rot2. Oh yeah, we should trim one of these. Okay, finally. Okay. Great, and pressing left rotates this cube. This looks good, and so now we want to, and yeah, hold it down. No funny business happens. So now we want to get the right. Let's implement. Okay, let's save what we've done so far. Good knows it took us a while to get here. Started, made left arrow rotate the cube. And let's just push this to GitHub. Okay. Okay, zig out, then. Okay. So I think it's working. So now what's the time? Half an hour to midnight, we will get there. We now want to do like the key right. So we can just literally copy all of this, but now replace left with right. And then go back to the globals and do something similar here. Okay. But now when we update this, we want to make sure that we're multiplying this by, we're doing this multiplication like 3 times. So we can do this. This is where like Zig now beats Odin. Because in Odin, doing the following thing would result in an error, which would be totally ridiculous. So now like the ridiculousness is shifted from Zig to Odin. So now if I go back to the definition of this thing, I want to just, because it's easy, literally just say this matrix here is equal to matrix multiply the rotation matrix that's 90 by the rotation matrix that's 90, and do this again with like do the multiplication 3 times. This would be impossible in Odin. It kind of would also just be easy to just literally insert the correct numbers here. Because inserting the correct numbers would just be changing one to a positive one, I think. But I like this more. This is fine. Okay, so now when we're doing the right key, we just want to be doing this by 270 instead. Okay. Let's just check this is working. So yeah, pressing the left key does that, pressing the right key moves it around the other way. So let's see, it's yellow, blue, green, dark green. So it's yellow, blue, yellow, blue, green, dark green. So that should be dark green, that should be light green, blue, yellow. Yeah, this seems to be working. Great. So now let's add in the corresponding key up and key down. So we've now done right. Yeah, same thing here, but now it's just replace right with up, and then replace up with down. Oh, okay. Yeah. So this really could like update. Check to see how pressed keys are. And then we also just want to have corresponding logic for these. So in this case, we want to do that. Replace right with up. And then replace right with down, and then do the corresponding thing. So now we're rotating by 90 degrees around Z, and by 270 there. So let's just make the corresponding globals. Starting with these ones, and then replace right with up, and then let's just align everything to that. Okay, we're getting there slowly. And now we need to define just like a 270 matrix. So now just replace the x's with the z's. Okay, let's get this going. So yeah, this works as intended, and now okay, pressing, this is not the direction I wanted. So I want the yellow to be moving, but it looks like we're actually, what axis are we rotating around? This is, something is not right. Something's very wrong. Like the thing is, like, I know if we do this with quaternions, like it will work. I just want to try and do it with linear algebra first, because apparently it's like, it was easy in my head, and now it's like, now it's not working. But I think this is just a bug in the code and not a conceptual bug. Because yeah, what even are the directions in this thing? Yeah, looking at this, okay, so we're looking, where's the camera direction? So, come on, it was like, if I search like towards, this was, okay, so we're currently at 10, 10, 10, and looking towards the origin from memory. Yeah, the camera target is, okay. And then okay, currently like the dark green is on the top, so Actually, I think there's an easier way to debug this, which is literally just to draw cubes at that are not being rotated at predetermined positions. Let's just do that. Okay, so let's just say like pos A is 0, 0, 1. We've already got some unit stuff though, right? Yeah, so let's actually just draw, we don't even need this. Let's just simply, this is totally debug, but let's just render the cube 1 at unit X. We're gonna have to adjust like the, okay, let's make like a red cube along the x-axis, and this is just like the identity matrix. And then we'll make like a green cube and a blue cube along the y-axis and the z-axis. Okay. So let's just do like red cube. Red, and then we'll just, we can do this with macros. Red, comma, enter. And then likewise, we'll make a green cube and a blue cube. So let's replace red with blue. Oh, and Emacs does that. That's really nice. Green with red with green. Okay. Now let's just render everything again. Oh. Oh yeah, we need to define these colors. Oops. Constant red equals color 0x ff 0000 ff. Yeah, blue is 00. That's this one. And then green is 0. This. Okay. Oh, come on. Oh, yeah, we just need to convert this identity matrix, that's right. So, what is it called? Like, mat 33i8 2. Okay, now we know the directions. Okay, thank goodness. So curiously, yeah, X is that way and blue is that way. Okay, so now, yeah, rotating along the x-axis is doing this, which is like the counterclockwise direction along the x-axis, which is fine. But then in terms of the z-axis rotation, that's not what we want. The z-axis should be rotating in a different direction. Did we stuff this one up? Or was it? Oh, okay. This might be a copy pasta issue. The mathematics is maybe fine. I think like maybe when I copy pasted this, I like didn't. I mean, this kind of does look fine actually. Yeah, up and down. Just update these matrices by multiplying things this way. Okay, let's start this again. So if I'm just pressing up and down, what's happening? Oh no, like yeah, there's something like fundamental going on. They're like quaternion solved. So why? Yeah, like what's wrong here? Why is like if I have something in this position and then I immediately say just do a rotation around the x-axis, why does this not move like this brown face of the cube to the other face? Like this is for whatever reason I was like, oh, there's no need to do like quaternions, like just keep track of these directions with just a single rotation matrix, and then this happens. It's probably because I'm like assuming some things are commuting and things are not, and then that's leading to this disastrous behavior. Oh, I think it's because I'm like rotating this with respect to some like frame of reference, and yeah, I think this is what's going on. So let's see. If we just do x-axis rotations, that is the red cube. Yeah, we can like move this yellow up and down. So let's say we move the yellow on top. Well, okay, what's the starting configuration? Starting configuration is dark green on top. Is okay, gray, dark green, light green. So yeah, if we like rotate it so that dark green is on the bottom, that is this, and then do okay, or use so just rotating it along the x-axis, fine. Just rotating it along the rotating this along the z-axis is not working either. Really? Okay, no, it is. I was pressing the wrong button. That's why. So yeah, just rotating along the z is fine. And then, yeah. So yeah, this is x. And then, this is the Z. Okay, so what happens if we rotate by like 180 along the X and then do the Z? What do we expect? We expect the yellow to remain consistent, which it is, but now the green is going in the wrong direction, and so what's happening here? So here, yeah, I'm still like, yeah, what conceptually is going wrong? Yeah, clearly thinking just rotation matrices work is not enough. It's like a while ago, like I did something in quaternions and it worked, and I was just like, that was totally expected, but this is not expected. Yeah, I think it's because I think it's because I'm expecting the axes which we're rotating these around to remain fixed, but in reality, like, they're not. So let's see. Yeah, so if we're just doing the x-axis, yeah, everything, like, stuff is like flipping around, but the x-axis is remaining the same, which is why it works as expected. Likewise, if it's just the Z from the starting position, other stuff is flipping around, but Z is fixed, so it looks fine. But now let's flip the x by 180. What's now changed? So now the Z is actually facing the other direction. And so now when we do the Z, when I expect the light gray to go upwards, it in fact goes down. Yeah. Because that axis is facing the other way. And likewise, okay, and then, okay. Yeah, I see the problem now. So, okay, you do this enough times, and then you just you truly learn why quaternions like solves the problem, or really why there is a problem to begin with. Okay, and so is there some easy way out of this? Is there a way to just keep track of the direction, like the axes actually, and compensate for it? There is, but it's basically midnight. Damn it. Oh, hang on. Part of this might actually be how we're doing the matrix multiplication. If we're not consistently multiplying everything on the left, this is going to stuff up. Okay. Since obviously matrix multiplication is not commutative. So how are we doing this stuff? Oh, yeah. No. We want to be, yeah, okay. Maybe everything's actually fine. Maybe this problem is just due to, yeah, due to this. Okay. So let's have the main cube rotation here. I don't know why that just occurred to me. Okay. Like in general, all of like matrix multiplication should be done on the left, unless otherwise. Okay, so now, yeah, the left and right work as usual. And then, what, does the up and down work as expected? Yes. Okay, so now, like, okay, let's do the previous example where we rotate by 180 around the x. Now if we do the z. Oh, and the z works. Okay. Okay, good. There wasn't actually something massively conceptually wrong there. It was just you have to multiply on the left. That's all it was. Okay, fantastic. These rotations seem to be correct now. So yeah, let's say we do like, yeah, say we rolled the cube like that way, then that way, then back that way, then this way, and then like round a couple times this way, and then left sometimes, and then now we rolled it that way, and then upwards, and then downwards, and then okay, yeah, this seems to be fine. Great. So I think we're gonna call it here for tonight once we save this, and then next time we'll add in the animations so that pressing this actually like smoothly rotates it, and then we're gonna have to modify the position to move correctly, and then we need to add an animation for the position movement as well. But yeah, there was so much unexpected linear algebra tonight, but that is okay. Seems to be working. So we need to add in like to do this is like simplify the linear algebra calculations using the fact that the matrix types have using, so this is like maybe using vector 3 types. Okay. But okay, let's just make, I want to convince myself one last time this is working. So let's see where you rotate it this way. Then let's rotate it that way. Then we rotate it back, and then kind of down. Then say down, 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 then that way, then that way, that way, that way, then that way, then that way, then that way, then that way. Okay, this seems to be working. Great. Git status. Yeah, we added in a lot of queries tonight. Sig, but that is good. Always better to be writing code than reading it, since reading it sucks. So yeah, git commit yeah, made cube rotate. Well, made cube rotate, made cube snap rotate correctly with arrow keys. And off that goes, and yeah, look how wonderful Windows PowerShell is. It's just like, it doesn't clear all of this stuff, it just overlays it. Because Windows is confident. Okay, thanks everyone for who came by and watched. And yeah, this is good. Like very soon, the cube will be correctly, like will be smoothly rotating and smoothly moving positions, but without the crap in other games where you press the arrow key twice and it just moves once because the animation takes a second to play out. That's not happening in this. Our game is gonna be snappy, very, very snappy. Okay, bye everyone.